for 7.1 part 2. We're going to talk about cube roots, not just square roots, and then we're going to talk about even bigger roots, like 4th root, 5th root, all kinds. So if we see this, it's like a square root symbol with a little 3 on the outside. That means we're looking for the cube root of a. So that means we're asking ourselves, what times itself 3 times equals a? And we did this last year. I think we've even talked about it this year already. Yeah, we talked about it this year because we factored squares of cubes and differences of cubes, right? So let's talk about what the graph would look like. So if we graphed y equals the cube root of x, we're just going to do kind of like yesterday, we'll make like a little graph just to show what it looks like. So if we make an xy chart here, I'm going to start with -8 for my x. Could we take a cube root of a negative number? We couldn't do it for a square root. We couldn't do a negative. We could have a negative number times itself 3 times, and that ends up negative, right? Because negative times negative is positive, times another negative, that's negative. So we can do negatives inside cube roots. So what's the cube root of -8? -2, right? -2 times -2 is 4, times another -2 is -8. So we can do cube roots and negatives. What's the cube root of -1? -1, right? Because -1 times -1 is 1, times the third -1 is -1. What's the cube root of 0? 0. What's the cube root of +1? What's the cube root of +8? 2, because 2 times 2 is 4 times 2 is 8. So we're gonna graph that, just like a little sketch of a graph. You don't have to be using graph paper. So let's see. We're gonna start with x is -1, 2, 3, 4, 5, 6, 7, 8. So this one stretches pretty far left and right, because I had to go all the way to -8 to get the next perfect cube. So if I'm at x is -8, that means y is -2. If x is -1, y is -1. So we go all the way over to right here. Like there's gonna be points in between, but that's the next like whole number I could do. And then 0, 0, and then 1, 1, and 8, 4, 5, 6, 7, 8, 2. So this graph, it's curvy, but it's kind of hard to see it. It looks like this. And it will keep going up and it will keep going down. It just is like really gradual. Because it takes a long time to get another perfect cube. Yeah? So let's write down a little note to ourselves that the cube root... Well, sometimes when this happens, I'm worried that it like stopped the video for some reason. I know, but sometimes it is still going, but there's no sound. Well, we're just going to do it anyway and see. Alright, so we're going to write down that the cube root... Yeah. The cube root of a positive is positive. And the cube root of a negative is negative. So with square roots, we could only take the square root of a positive. Cube roots, you can do positives or negatives. It's fine. Alright, let's do some examples. So our example is, I'm going to give you a function, f of y equals the cube root of y. And then we're going to find some values of y. Like we're going to plug in some things for y. So we're going to find f of 125. If you know it, don't say it out loud, just write it down. We're going to find f of 125. So that means we're just plugging in 125 where we see the y. So that means we're doing the cube root of 125 What times itself 3 times is 125, Liv? 5. 5 times 5 is 25, times another 5 is 125. Let's do another one like that. So we're going to do a function g of x, and it equals the cube root of x minus 1. So we're going to find g of negative 26. So that means we're going to plug in a negative 26 wherever we see an x. So we're going to do the cube root of x minus 1, so we're going to plug in negative 26. Negative 26 minus 1. So that's the cube root of negative 27. Raise your hand. Who can tell me what times itself 3 times would give me negative 27? Macy? Negative 3. Good. Cube root of a negative is negative. Okay, let's do another example before we write down more stuff. One more example of a cube root, and then we'll go to bigger roots. So we are going to simplify the cube root of negative 8y to the third. When I do a try on your own? Oh, here's what I do. I say, okay, here's what I want you to try on your own. Pause the video and try it. And then I just click to the next page and I just start writing the next thing. Yeah. Doesn't take me any time at all. Alright, so let's look at this one. So we want to know, can we write this in here as something being cubed? What times itself 3 times is negative 8? Negative 2. And what times itself 3 times is y cubed? Y, right? We can write this as negative 2y all cubed. Yeah? So yeah, it's kind of like, I remember a square root and a square cancel each other out yesterday? On this one, oh sorry, I forgot the cube root. A cube root and a cube, they cancel each other out. They kind of undo each other. Because it's like, we're asking ourselves, what times itself 3 times is negative 2y cubed? Well, negative 2y times itself 3 times is negative 2y cubed. So this is just negative 2y. And on this one, you do not have to put the absolute value sign around it, because it's okay for it to be negative. No, because it can be negative. Alright, we're going to move on to bigger roots now. Let's go. Alright, so we're going to talk about the difference between if we have odd and even nth roots. We just write nth because that means we could be taking the root of any number n. We could be taking the 100th root. Like, what times itself 100 times gets us this number? No. So if we see this, that means we're taking the nth root of a. Like, n could be any number. We could take the cube root, we could take the 4th root, the 5th root, the 6th root. So this is the nth root of a. So we're going to first talk about when we're taking an odd root, like a cube root, and then we'll talk about when we take an even root. So, to me, for some reason, I feel like odd is like a red color, and even is blue. Don't you think? Yeah. No, it's not. Okay, so when n is odd, so we're talking about any odd root. So the cube root, a 5th root, a 7th root, a 9th root, an 11th root, a 13th root, any odd number. Here's all the things that happen. There's one real root. So like if we do a cube root, there's just one answer. It's either positive or negative. If you do a square root, there's a positive or negative answer. What did I write this down for? I wrote odds have odd roots. Evens have. Oh yeah, that makes sense, right? Like an odd number like 27 has an odd root, 3, if we're doing the cube root. Okay, that makes sense. So odds have odd root. Is that what I meant to write? Let me just double check that. So if we're taking the root of an odd number, like 27, it's going to have an odd root if we're taking an odd root of it. Let me look up, but make sure I meant to write that. Has one real root, odd roots. Oh, I wrote this down wrong. Okay. We'll just cross it out. I was writing these at conferences, so I was probably like kind of distracted. Just this one line. Okay, what I meant to write was if we're taking the root of a positive number, it's positive, and of a negative number, the root's going to be negative. Whoops, sorry. I knew that's what I meant. It just sounded weird. Well, no, we're not rewriting it. We're going to write something different. All right. So if you take the odd root of a positive, the answer is positive. Like if we take the cube root of positive 27, we get positive 3. If you took the fifth root of positive 27, you'd get a positive number for your answer. And if you take the odd root of a negative, you get a negative. Yeah, that's fine. So if you're taking the odd root, like the cube root of negative 27, you get negative 3 as your answer. You get a positive answer if your radicand is positive, and you get negative if it's negative. And then the last thing we want to write about if you're taking an odd root is that there is no need for the absolute value sign. Because it could be positive or negative. It doesn't have to be positive in there. So if you're doing an odd root, you don't need the absolute value sign. Alright, we finished the first half of my page. Now I gotta do the back. Oh, that's not bad. If it's half and half, that'd only be 24. Yeah, Jamie and Carson. Alright, so we're gonna do 6 examples. No. No. Yep. That's why it's good to do when people are absent. Alright, write all those down. Yeah, just a little room. They're each just like one number for your answer. We've got to do these. We've got to write about when the root's even, and we got to do 6 more examples. Oh. Oh, I meant to make this one a negative 32. That doesn't really count. Sorry. Try to think about what times itself 5 times would get you 32. Don't say it out loud. Just try to think about it. Shh, Clay, just think about it. Alright, do you guys have time to write these? Alright, raise your hand if you have figured out what times itself 5 times gets you 32. Piper? 2. Good. 2 times 2 is 4, times another 2 is 8, times another 2 is 16, times another 2 is 32. So what times itself 5 times would give you negative 32 then? Negative 2. Because if we do a negative times itself an odd number of times, we're going to end up with an odd with a negative. So then on this one, we want to do the 5th root of 32, which is 2, and then we have a negative on the outside, so we make it negative 2. The negative on the outside means change the sign of whatever you got. So on this one, let's change colors. On this one, if we don't look at this negative sign out front, if we just look at this, what's the 5th root of negative 32? No, what's the 5th root of we did it right here, right? Negative 2. The 5th root of negative 32 is negative 2. If we multiply negative 2 times itself 5 times, we get negative 32. But there's another negative out here, so it changes back to a positive 2. So you've got to really be careful with your negatives. On this one, we're taking the 7th root of x to the 7. Raise your hand if you think you know what that what would happen to that one. Jeb? Just x. If you have a 7th root and a power of 7, they just cancel each other out. Yeah? Is it an odd or even root? Is it odd or even? 9 is odd, right? Is there a need for absolute value signs for odd? No, no need for it. So it's just t minus 1. Yeah? Yep. As long as it's the same number here and here. Those will just cancel out, and you're left with whatever's in there. All right, let's talk about even roots. Yeah? Yeah? They would not cancel out. Well, we'll talk later about what would happen if that happens. I don't want to confuse you right now. So let's talk about if we have, let's remind ourselves, we're talking about the nth root of a. So if n is even, we're going to write down some things that happen. If n is even, so we already talked about if n was odd. So if any times n's even, so if you're taking like a square root or a 4th root or a 6th root or an 8th root, whenever that happens, you're going to always have 2 real roots. One of them is positive. We can do that for positive. One of them is negative. So anytime you're taking an even root, you have 2 real number solutions. Now, if we're taking an even root, like a square root, we can't put a negative number in that square root. We can't do that because there's no number times itself an even number of times. If it's negative, that will get us a negative. So negative numbers do not have real roots when n is even. So if we're taking an even root, we cannot have a negative number inside that square root symbol. If you're taking a square root, a 4th root, a 6th root, an 8th root, you cannot have a negative number in there. And any time that you just see like the nth root of a, like you see it like that with that symbol written, that means that they're indicating that they just want the non-negative root. Which I feel like this sounds a little contradictory. We're saying that the cube root of the nth root, if n is even, has 2 roots, but if we just see the symbol, we're only talking about the non-negative. That's kind of weird. Like, it really does have 2 real roots, but if I ever ask you for something and then all you see is the symbol, I only want the non-negative one. If I say, what are the 2 real roots of this number, then you'd have to give me the positive and the negative. All right, 1, 2, 3, 4, 5, 6 more examples. Copy it down from someone. Alright, get those written down. And if you finish writing them, try to think about what times itself 4 times would give you 81. Don't say it out loud, just think about it. It's a whole number. What times itself 4 times would give you 81? Don't say it out loud, just think about it. Alright, let's go over these. So raise your hand if you've thought of the number that is the 4th root of 81. So what number times itself 4 times gets you 81? Elise? 3 is right. 3, so if we do 2 of them, 3 times 3 is 9, times 3 is 27, times another 3 is 81. So on the next one, the negative sign's on the outside. That means we find the 4th root of 81, which is 3, and then we make it negative. So it's negative 3. Raise your hand if you think you know what C is, the 4th root of negative 81. Tyler? Negative 3 times negative 3 would be positive 9. Times a negative 3 would be negative 27. Times a negative 3 would be positive 81. That wouldn't get me negative 81. No real solution. So if we have an even root, square root, a 4th root, a 6th root, we cannot have a negative number inside of there. That would make it no real solution. Yeah, it would be 3i if you wanted to write it like that. All right, on D, let's see. If you've got this, if it's a product in here, so things being multiplied by each other, you can just think of it as finding the 4th root of each factor separately. If there was a plus or a minus, it would mess everything up and you couldn't do it. Okay? So what's the 4th root of 81? 3, right? What's the 4th root of x to the 4? X. So your answer is 3x. So you can just think about it separately. You can just think about it separately as long as it's a product in here, as long as it's things being multiplied. If there was a plus right there, you wouldn't even be able to do it. You would just not do anything. Well, because you have to take the 4th root of 81 as well, not just of x to the 4th. What's it going to do it on this one? It's funny, because I was going to put it on this one. We definitely would need it. I feel like we would need it on that one too then. Yeah, I think we have to put it. On this one, we don't have to put it. Why would we not have to put absolute value on this one? Jeb? Right, there's no variable. It could never be negative. Good. Is your picture already up there? I feel like yours is. Okay. Yeah? I didn't put yours? Oh my goodness, I'm so sorry. I'll make sure I still have it. I might have deleted it. Otherwise, I'll take a new one. Are you sure? Oh yeah, I did. Okay, I'll put it up. I'm sorry. I'll do Esther, yours, and then I had someone in another class I need to do. Yes, absolute value. All right, one last example. We're going to determine. It's a really short one if you can fit it somewhere. If you can fit it somewhere little, it's short. We're going to determine the domain of g of x equals the sixth root of 7 minus 3x. You guys did problems very similar to this towards the first couple months of this year. Yeah, it's a 6. So if we're taking an even root, what cannot be inside the square root? A negative. So this stuff in here can't be negative. So if it can't be negative, 7 minus 3x can't be negative. What does it have to be bigger or equal to then? Bigger than or equal to 0, right? It's got to be greater than or equal to 0. I'm just going to make a little note to myself here. The reason I did that is because 7 minus 3x can't be negative. So it has to be bigger than 0 or it could be 0. So then we're just going to solve this inequality just like we would have done at the beginning of the year. So remember, there's kind of like, we haven't done this in a while. We're solving this. So raise your hand, what should I do first to get x by itself? Liv? Subtract 7 from each side. So we're left with negative 3x is greater than or equal to negative 7. Raise your hand, what do I have to do next to get x by itself? Jake? Good. We divide by negative 3, and if we divide by negative, we flip that inequality sign. Good. So it's x is less than or equal to positive, let's just leave it a fraction, 7/3. Sorry, that says, let me write that again. X is less than or equal to 7/3. So that's how we would write it in the inequality notation. What if I asked you to write it in interval notation? What's the smallest thing x could be if I said it has to be less than or equal to 7/3? Negative infinity is the smallest thing it could be, right? What's the biggest thing it could be? 7/3. Does the negative infinity get a parentheses or a bracket? Does the 7/3 get a parentheses or bracket? Bracket, because it could be equal to it. Good. Jeb? Okay. All right. Well, that's the end of the video for like the 2 people who watched the video. Good night.